So till question 12 I have recorded. I will solve question 13 from astrophysics. In question 13, light from either end of a sun diameter is analyzed and compared to a light from a center of the sun. So we are observing the light, like example, from either ends. So observing the light from either end with the center of the sun. And a hydrogen line in the in light from the center of a wavelength 490 nanometer is shifted by 3.4 into 10 to the power minus 3 nanometer compared to light from the center. Calculate the value of the angular velocity. Calculate the value of the angular velocity of the sun. So sun is not stationary. Sun is also moving, spinning. So because that's why there's a shift. Because if it was stationary, if it was not move, if it was stationary, then there should not be a shift in the wavelength. Because it is moving, that's why there's a change in wavelength. So we want to determine, and the diameter of the sun is given, which is 1.4 into 10 to the power 9 meters. So we want to determine at what speed it is moving or spinning, because angular velocity is there. So first, we have the formula, like the Doppler shift is there. The Doppler shift Z, that is change in wavelength over original wavelength. Okay. That's how we use the Doppler shift, the change in wavelength over original wavelength. And Doppler shift is also, it is V by C. So we can compare, like first we can work out Doppler shift and then substitute in the value. This is one way, or you can directly compare these two, that because one is Doppler shift is change in wavelength over original wavelength, or speed divided by c. So if we compare them, these two equations, so lambda change in wavelength over original wavelength is equals to speed at which the object is moving divided by c, which is the speed of a light. So when we substitute these values, if we want, first we determine the speed at which it is moving. So this v. So delta v divided by original wavelength into multiplied by speed of a light, that will give us the speed at which it is moving, the linear speed. And to work out the angular speed, today we'll discuss the angular velocity formula, that is v is equals to r omega. So if we need angular velocity omega, it will be equals to v over r. And the diameter is given, so we'll work out the radius. So the change in wavelength, according to a question, the change in wavelength is given 3.4 into 10 to the power minus 3. The original is 490. The speed of a light is 3 exponent 8. This will give us a speed that is about 2.08 into 10 to the power 3 meter per second. We get speed. Now we need omega. So omega is v over r. V is the speed, which is 2.08 into 10 to the power 3 divided by r. As I mentioned in the question, they mention a diameter, but we need the radius, so half of a diameter. So it will be 1.4 exponent 9 divided by 2. So it will be 0.7 into 10 to the power 9. So when we divide, we get the value for omega, which is 2.97 into 10 to the power minus 6. And the unit is radian per second. That's the angular speed. So actually what is happening is the sun is not stationary, it's also spinning. So as it is spinning, that motion is causing, like that's the speed at which it is moving, or how many angle, or what is the change in angle every second, that is called omega. So omega, we can determine this omega by the speed. If we know the speed at which the particles are moving and the radius, so we can work out the omega. So this was question 13 from Astrophysics and Cosmology. Now we'll start the circular motion.